As home to one of the largest oil deposits on Earth, Alberta's oil sands play an important role in providing a secure and reliable energy source to help meet the world's growing energy needs. Shell mines heavy oil from its Athabasca oil sands project in northern Alberta, Canada, and pipelines it to its Scotford facilities, 50 kilometers northeast of Edmonton, for further processing. Since starting up its mining operation, innovation and technology have played a key part in Shell's efforts to reduce the environmental footprint of its oil sands operations. Now, with its Quest project, Shell is leading the way in becoming the first oil sands operator to implement an important technology called carbon capture and storage, or CCS. Identified as one of the most promising technologies to combat rising CO2 emissions from large-scale fossil fuel usage, CCS captures CO2 from industrial facilities so that it does not enter the atmosphere and injects it deep underground. Shell's Quest CCS project will capture more than 1 million tons per year of CO2 emissions from its Scotford Upgrader and inject it deep below ground at a site north of the facility. The project will combine existing technologies used by the oil and gas industry for decades to capture, transport, and inject CO2 underground. At Shell's Scotford facilities, heavy oil from the mine is upgraded into synthetic crude and then refined into products like gasoline. The upgrading process involves adding hydrogen to the heavy oil. Producing this hydrogen generates one of the largest sources of CO2 emissions from the upgrader. Using a Shell-patented amine technology, Quest facilities will capture this CO2. Hydrogen and CO2 from the 3 hydrogen manufacturing units will be piped to absorber vessels in the capture facilities. An amine chemical in the vessel absorbs the CO2, and the hydrogen is returned back to the hydrogen manufacturing units. The amine and CO2 are pumped into another vessel, where the CO2 is separated by dropping the solution pressure and by heating. The amine is returned to the absorber vessel, and the CO2 is sent to a compressor. The CO2 is then dehydrated to remove the water and compressed into a dense fluid for transport. Liquid CO2 will be transported by pipeline to between 3 and 8 injection wells located north of the Scotford Upgrader. The Quest pipeline will be designed, constructed, and operated to the highest safety standards and continuously monitored from the Scotford site. Alberta's geology is ideal for the storage of CO2. The underground formation where the Quest CO2 will be injected was selected with safe storage and permanent containment in mind. Located deep below the surface, the porous rock storage formation lies about 2 kilometers beyond the deepest drinkable groundwater and about 1 kilometer below the deepest hydrocarbon deposits in the area. The CO2 will be injected into a porous rock formation, displacing the salty water which is already present and becoming trapped in the tiny spaces within the porous rock. With time, an increasing percentage will dissolve into the water and sink to the bottom of the formation, and the CO2 will become even more firmly trapped. Multiple layers of shale and rock salt that are above the expansive storage formation provide impermeable barriers to keep the CO2 contained. Shell will put in place a rigorous world-class monitoring program to provide assurance that the CO2 remains safely and permanently underground. Once it starts storing CO2 in 2015, Quest will not only reduce emissions from the Athabasca oil sands project, it will provide knowledge that will help to accelerate the adoption of this vital technology around the world.